Number 18, complete the table and graph using the given equation y equals absolute value x plus 2. Okay, before I even start this, I know that this is the absolute value function, so I know it has to look like a v when I'm done. So if it doesn't look like a v, I did something wrong. Okay, when I plug negative 5 in, this is going to be negative 5 plus 2. Okay, negative 5 plus 2 is negative 3, and these bars make my answer positive, so negative 3 becomes 3. Okay, negative 4. When I plug in negative 4 plus 2 is negative 2, but the bars make the negative 2 positive 2. When I plug in negative 3 plus 2 is negative 1, but then when I use the bars, it becomes 1. And then negative 2 plus 2 is 0. Well, the bars will just keep it 0. Negative 1 plus 2 is 1. The bars just keep it 1. 0 plus 2 is 2. The bars just keep it 2. And 1 plus 2 is 3. And the bars just keep it 3. Okay, so now I'm ready to graph. I think most of you, I circled this part right here because that's where you made the error. You kept those negative, but absolute value signs make those numbers positive. Okay, sorry about those crooked lines, but here we go. Okay, negative 5, 3. Go to the left 5, 1, 2, 3, 4, 5, and up 3. And I'm going to go to the left 4 and up 2. And then I'm going to go to the left 3 and up 1. And I'm going to go to the left 2 and stay put. The negative 1, up 1, 0, 2, and 1, 3. And notice I did get a V just like I was supposed to get. So there we go on that one. For 19 through 22, decide if the following represent functions or not. Explain why or why not to receive full credit. Okay, if you look at number 19, my two ones in question would be 2, 8 and 2, 7. And I noticed that they both have the same item, so this is basically saying that item 2 is $8 and item 2 is also $7, and that is not okay. So I'm going to say no, and my reasoning will be because 2 has 2 outputs, and that is not okay. All right, number 20, y equals 4x squared. When I see this, I notice that it is a member of the quadratic family, so that is why it is definitely a yes. And I'm going to say yes, it is a member of the quadratic family. Some of you had said a yes, but you told me exponential family instead of quadratic, but it is definitely quadratic. Okay, 21, I'm going to use the vertical line test, and I just get to draw one vertical line because I notice already that my vertical line goes through that graph 2 times. So this is a big no, and I'm going to say it fails the vertical line test. And most of you did great with telling me that vertical line test was VLT, and you defined it. So thank you for doing that if you did. Okay, 22. A teacher makes a table that lists the student's first name X and the student's last name Y of each student in the class. So I'm going to make an X and a Y. Notice in this one, it doesn't say how many letters are in the name. It says it actually lists the name. So I'm just going to list a couple names here. Let's say I do Joey, Janet, Petey, and I could keep going. And then the student's last name, well, let's say Joey's last name is Smith. Janet's last name is Cobb. Petey's last name is Johnson. Okay, and then I basically need to see, is this always going to be a function? And I'm going to make it not a function right now, because I could have Joey, and then I could put Brown. So notice I've just made it not a function because Joey is the same input, but it has 2 different outputs. So I'm going to say no, and I'm just going to say some of you did a great job of explaining, because 2 kids could have the same first name but different last names. And some people gave me an explanation, something to do with they might have the same last name. That would be okay if they had the same last name, because it's all right for different people in the family to have a different first name, but you all share the last name. So you have to just be careful on that. Okay, next problem 23. The county fair charges $5 admission plus $1 for each ride you ride on. There are 10 different rides at the fair. The total cost of the Carnival Experience C is a function of the number of rides you ride R. Okay, so it says A, identify the independent and dependent variables. The independent is going to be the one that I get to choose, and I just definitely get to choose the number of rides I ride on at the fair. Okay, and then the dependent variable is what's going to depend on how many rides, and that's going to be the total cost. All right, next one, it says make a table for all values, for all numbers in the domain. So we want to think of all the possible situations. So I could actually go on no rides if I'm not really a ride person, all the way up to the 10 different rides that they have. So I want my table to go all the way up to 10. Ooh. Okay, if I don't go any rides, I still am assuming that I got into the fair, so it's going to cost me $5 just to get in. Then if I go on one ride, it will cost me $1, and then I'll just keep going up by $1 each time I add another ride in. So that's all I'm doing right here. And technically, I suppose this could keep going if I went on some of the rides more than one time, but we'll just assume that I only rode on each ride once. So there's my table. And then it says to identify the range. The range is just my y values, and they go from 5 through 15. Okay, number 24 says to identify the domain in the range. I find this helpful, first of all, to make a list of my x's and my y's. So that first point is -2, 11, -1, 8, 0, 5, 1, 2, and 2, -1. And if you remember, the domain is just a list of all the x values. So this is just going to be -2, -1, 0, 1, and 2. And then my range is just all the y values, which will be 11, 8, 5, 2, and -1. Some people put those in order, that's fine, or we could put them just how we have them. All right, 25. Let f of x equal 1/2 x plus 3. First of all, find f of -4. Remember, if we have something in parentheses, we're just going to put that in place of the x. So I'm going to have 1/2. Instead of the x, we'll put -4. And then 1/2 times -4 is -2, plus 3 is 1. And then f of 0, wherever I see an x, I'll put 0. So this will be 1/2 times 0, plus 3. 1/2 times 0 is 0, plus 3 is 3. And then the last one, f of 6, wherever I see an x, I'll put 6 this time. So 1/2 times 6 is 3, plus 3 is 6.